So let's go over your homework from lesson 8.1 and see how you did. And hopefully with me solving each one of these, it'll help clarify some questions you might have or give you some more practice so you feel a little bit more comfortable with it. The first one is simplifying. It says 27 to the 2/3 power. Remember that the numerator is the exponent and the denominator is the root. So in this case, we have the cube root of 27 squared. Again, if you don't have your chart that had your perfect roots on there, you need to hopefully find it or print off another one online. If you Google it, you should be able to find one. The 27 is a perfect cube. It is 3. So that goes away, and we have 3 squared, which is 9, and that is your answer. And number 2, 32 to the negative 1/5 power. Again, 5 is the root, negative 1 is the exponent. 32 is a perfect 5th root. The 5th root of 32 is 2 to the negative 1 power. What does that mean? That does not mean negative 2. That's an exponent. And when an exponent is negative, it moves to the denominator. When I move it to the denominator, 1 goes in the numerator, and the 2 to the first power, which is now positive, goes to the denominator, which is equivalent to 1/2. Now we have here the base 7 to the negative 2/3 power, that whole thing raised to the 3rd power. The best thing to do with this is to multiply these. Multiply the exponent to the power. And you do it by multiplying the numerator. Negative 2 times 3 is negative 6, and 3 times 1 is 3. Well, we can simplify negative 6/3. That's the same as negative 2. Again, we have a negative exponent. We can't have a negative exponent. It does not mean that you multiply that by 2 and make it negative 14. It means that we are moving the base and the exponent to the denominator and making the denominator positive. And 7 squared means 7 times 7, which is 49. So your answer is 1/49. Finally, the last one is negative 9 to the 3/2 power. We have to take this base and we have to pull that negative 1 out separately so that we can do 9 to the 3/2 power. And remember that the denominator of the 3/2 is your root, so that's the square root of 9 cubed, and we still have the negative 1 out front. Square root of 9 is a perfect square, that's 3, and we cube it. We want to cube this first before we multiply by negative 1, so it's 27 times negative 1, which is negative 27. Again, not all of these are similar, so there's a lot of different approaches to these, so that's why I want to go through them. 5, 6, and 7 says write in exponential form. All answers should have positive exponents. All right, exponential form, remember, you can take something from an exponent and it's equivalent to a radical. So we're taking it out of radical form and turning it into an exponent. We have to make sure all our exponents are positive. So if there's nothing there, in this case it's a square root, there's a 2 there. So to take this out of radical form, this becomes x, the exponent's the numerator, the root is the denominator. So that's x to the 3/2, y to the 5/2. There's nothing else we can do with that, and we don't have any negative exponents, so we're done. Again, number 6, the square root of x to the 6, y to the negative 4th. There's a 2 there, so this is x to the 6/2 power, y to the negative 4/2. We can simplify 6/2. 6 divided by 2 is 3. We can simplify negative 4/2 and make it negative 2. We have this negative exponent. It has to move down. The x cubed stays on top. It's not moving. It already has a positive exponent. But the y to the negative 2nd is moving down and becoming positive. All right, let's look at the last one. 1 over the cube root of 8b to the 6c to the negative 4th. All right, well, the good thing is the cube root of 8 is a perfect cube, so it's 2. We're done with that. Now we're doing b to the 6 divided by 3. It's the exponent over the root. C to the negative 4/3. Okay, from there, b to the 6 over 3. 6 over 3 is 2. C to the negative 4/3. Well, can't have a negative exponent. If it's in the denominator, it moves to the top with the C. So this becomes the base C to the positive 4/3 over 2b squared. And we're done. I think these tend to be the most difficult, where you have them in radical form and it says write in exponential form and simplest radical form. This means that there's a different approach to all of these. So what I'm looking at is I notice I have the square root of 8 and I have this 6 times the 6th root of 8. The only way I could combine these if they had the same index, in this case root. We don't. We have a square root and a 6th root. So I have to take these out of radical and turn them into exponent to try and help. So this becomes 8. There's no exponent there, which means it's a 1. There's no root there, that means it's squared. Times 8, there's no exponent, it's a 1. And the root is 6. Now I have the same base. We use the rules for multiplying exponents with the same base, which means you keep the base and you add the exponent. So I'm adding two fractions, 1/2 plus 1/6, but I cannot add them that way because I don't have a like denominator. I'm going to have to multiply 1/2 by 3 over 3, and I get 8 to the 3, 6 plus 1/6. Now, to add fractions, you add the numerators. 3 plus 1 is 4. You keep the denominator. 4/6 can be divided by 2. So you get 2/3. Now, it says write in exponential form and simplest radical form. So now I'm going to take this and put it back into a radical. The cube root of 8 is a perfect cube. It's 2, and 2 squared is 4. Okay, let's go to the next one. The 5th root of 27 cubed divided by the 5th root of 9 squared. Okay, so you have to try to make connections about these bases. And the connection I can make is that I know that 27 is equivalent to 3 cubed. But I also have this other 3. So this is 3 cubed. It's like a power to a power. I know that 9 also can be made into a base of 3 because it's 3 squared. So now I have 3 squared, right? Because it was 9 squared. All right, I multiply these and I get 5, the square root of 5 cubed to the 9th power. Divided by the square root of 5, I'm sorry, I said this wrong. The 5th root of 3 to the 9th power divided by the 5th root of 3 to the 4th power. Okay, what do I know about the rule with the laws of exponents? If I have the same base, in this case I do, and the same index, I subtract my exponent. So this is going to be the 5th root of 3 to the 9 minus 4. And 9 minus 4 is 5. So now I get the 5th root of 3 to the 5th power. Well, what happens when you have something raised to the same power that you have index? It goes away. And this because it's really the same as 3 to the 5 over 5, right? And 3 to the 5 over 5 is 3 to the 1st, or 3. Again, here I'm seeing 27 and I'm seeing 9. So I'm going to make this the 4th root of 3 cubed times the 8th root of 3 squared. I'm going to turn these into exponential. So this is base 3 to the 3/4 times base 3 to the 2/8. Okay, so now I'm ready to go from there, and when I have the same base, I can add my exponents. So I get 3 to the 3/4 times, let's reduce this, 3 to the 1/4, because 2/8 is 1/4. So this becomes 3 to the 3/4 plus 1/4. And I can add them like they are because they have the same denominator, and we get 3 to the 4/4, or 3 over 1, which is 3. All right. I seem to like these well because I like solving and getting variables by themselves. So the goal is in number 11 to solve the equation. That means get a by itself. To get a by itself, we have to get rid of that exponent of 4/3. To make an exponent become 1, we multiply by the reciprocal, which is 4/3. We multiply by the reciprocal. Why do we do this? Because these cancel and all become 1, and we have a by itself. And 8 to the 4/3 means in radical form the cube root of 8 to the 4th power. The cube root of 8 is 2, and 2 to the 4th power is 16. All right, to get y by itself in number 12, first I have to get rid of this radical, or this exponent, which is a 1/3. What is the reciprocal of 1/3? It's 3/1. And this gets multiplied by 3/1. When I do that, that becomes 1, that becomes 1. Now I am trying to get to this y to get it by itself, but I had to get rid of the exponent first. Equals 4 to the 3rd power. 4 to the 3rd power means 4 times 4 times 4, which is 16 times 4, or 64. Now I'm solving this just like a two-step equation, and I'm going to subtract 8, and I get negative y equals 56, and then I have to have a positive y, so I'm going to either multiply or divide by negative 1 and get y equals negative 56. The last one, I'm trying to get t by itself. I can get rid of this 9 before I get rid of the exponent. So this becomes t to the negative 2/3 equals 4/9. How do I get rid of a negative 2/3? I multiply by the reciprocal and make this negative 3/2. So I multiply both sides by negative 3/2. That becomes negative, and that becomes 2 negatives make a positive. So we have t to the 4/9, which is raised to the negative 3/2 power. Okay, this is tricky. When you have a negative exponent, you can't do anything until you flip it. The denominator becomes the numerator becomes the denominator, and the exponent becomes a positive 3/2. Now I'm going to turn it into radical form. I'm going to do the square root of 9/4 cubed. 9 is a perfect square. It's 3. 4 is a perfect square. It's 2. Now I'm going to cube this. T equals 3 to the 3rd power divided by 2 to the 3rd power. And 3 to the 3rd power means 3 times 3 times 3, which is 27. And 2 to the 3rd power means 2 times 2 times 2, which is 8. So you get 27/8. Okay, I hope that helped you. And I hope you truly went back and checked it against your answers so that you feel a bit more confident. Now that you've finished this part, make sure you've printed off the class worksheet that you're going to do today and watch the next video, as I'm going to do a few of those with you. All right, see ya.